Okay, hi, good afternoon, everyone. Yeah, my name is Xin. I'm a core contributor at Origo. Today, I will going to give you an introduction about Origo. We are basically trying to build a platform to preserve the privacy for decentralized applications. Yeah, so first let's look at what is the problem. So we know that Bitcoin allowed us to transfer monies to peers without relying on a trusted third party. And Ethereum has made the advancement that basically allows people to not only transfer money, but to build decentralized applications that runs on blockchain. So basically, you can run any program that without relying on a trusted third party, and it has enabled people to do a lot of new stuff. For example, you can issue your ERC20 token, and you can do your crowdfunding, and you can also create crypto kitties and buy and sell crypto kitties. You can do a lot of other things like voting. And one potential problem of Ethereum is there is no privacy. Basically, everything you do on Ethereum is public to the whole network. The transaction you are doing, it includes who is sending the money and what is the receiver of the money and how much you are sending is public. And everything related with smart contract is also public. For example, the contract code is public, your input data to the contract is public, and how the contract is executed, the whole execution flow is public, and the execution result is public, and also any monies or tokens related with the contract is also public. So this might be okay for some of the applications, but it definitely limits some of the applications that requires privacy. And so recently, Zcash and Monero, they solved some of the problems. They solved the private transaction problem. So basically, you can choose to hide, for example, who sends the money, what's the receiver, and also you can hide the transaction amount. But that's only for private transaction. They don't support smart contracts. And any smart contract that deals with money still has no privacy. Yeah, so basically this is some comparison of what is the privacy in a transaction and what is the privacy for smart contract. So basically private confidential transaction can hide the sender's address, the transaction amount, and the receiver's address. But what they cannot solve is for smart contracts. They cannot hide the input data, the execution result, or any transactions associated with the contract. So we do think that, a lot of the real-world applications actually need privacy. For example, let's think about an insurance contract. For example, if it's for health insurance, then your health data is quite sensitive. You don't want everyone to see your health data and the price you pay for the insurance and what kind of insurance you are buying. It's actually very sensitive. You don't want these information to be public available. And also for a lot of the auction or gambling contracts, the input is also very sensitive. For example, in an auction, if you cannot hide your bid, then another party can basically, once they saw your bid, they can do a front-running attack to take advantage of that. He can just submit a better bid or so on. And also, for example, for voting contracts, in some scenarios, people want to hide who they are voting for, but they still want the result to be verifiable. So all those applications, it cannot be done on Ethereum with the preserving of privacy. So let's look at a real-world example. How do you play rock, paper, and scissors on Ethereum? Initially, you might think, oh, it's just easy. Just write a smart contract and let people enter their choice. And then you soon will realize that this simple approach has some problems, because if you just simply post your choice to the smart contract, your opponent can see your choice, and he can just change his choice accordingly to take advantage of that. So is there a solution for this? Yeah, fortunately, there is some solutions. So one common used technique is called hash reveal pattern. So instead of simply posting your choice to smart contract, it's trying to break this process into several steps. In the first step is called the commitment phase. So instead of directly entering your choice to smart contract, you will submit a hash of your choice plus a random string to the contract. The purpose of this phase is that you will not reveal your choice, but by doing a commitment, you will not be able to change it after the commitment is done. So after both parties made their commitments, then it goes to the next phase in the open. Basically, each party will reveal their choice and the random string, and the blockchain can verify that if this is indeed your choice. Because if you want to change your mind, for example, initially your choice is rock and you want to change to paper, since based on the property of the hash function, it's almost impossible that you can find another random string such that it hashes to the same value. So this pattern guarantees that once the commitment is done, you cannot change your mind. And after both parties has revealed their choice, and then we can execute the contract, determine who is the winner, and distribute the fund to the parties. So by using this protocol, the advantage is that the privacy is temporarily preserved. Basically, before the open phases happens, the commitments preserve the privacy. But the problem is that in the open phase, both parties still need to reveal their input to the blockchain. So this might be okay for an application like rock, paper, and scissors, because basically privacy doesn't matter once you know the result. But it does matter, for example, for those for the health insurance contracts. You don't want your information just to be leaked just after you purchase the contracts. So what is our solution? Basically, our solution is that we still do a commitment of the input, but instead of directly open the input onto blockchain, we will execute the smart contract off-chain to make sure that the private input is not leaked. And we will use zero-knowledge proof to make a proof that the contract is correctly executed, but without leaking the information. This is some general introduction about zero-knowledge proof. I don't want to go to too much detail. Basically, it can allow you to prove that I know some secret X without revealing any information except I know X. For example, you can use it to prove that you know your answer to a Sudoku without revealing what is the actual answer is. And for example, Zcash is also used it to prove that a private transaction is valid without revealing any information like who is the sender, receiver, and the transaction amount for that private transaction. And we will generalize that to use it to prove the correctness of private smart contracts. So this is our protocol, and it's 3 phases. I will describe each phases in detail. So basically, there are kind of like 3 roles in our protocol. Basically, contract participants, they want to keep their input and output private. And there are also a role called executors. Executors will execute smart contracts off-chain to preserve the privacy, and it will also submit a proof to zero-knowledge proof to prove that the computation is correct. And the blockchain will be used to verify the proof and distribute the fund to parties. And there are 3 phases. The first phase is commit. Basically, commit users will commit a hash of their input and their token value to the smart contract. And the blockchain will verify that the tokens that they committed is indeed valid, and it will freeze the coin to the contract. And in the compute phase, basically, each party, they will open their private input to the executor, and the executor will run this smart contract, and it will get the result, and it will generate a zero knowledge proof to prove the result is correct. And in the final settle phase, executor will submit the result back to blockchain, and we will use ZKP to verify that, okay, the result is correct, the input matches the commitment, and once it's verified is correct, and the blockchain will distribute the funds back to the parties. And this is a comparison of our Origo solution compared with the hash reveal pattern. So in the hash reveal pattern, it can only preserve the privacy of the input temporarily. Once it's been opened, then everything like the execution result or the output or the transaction, everything will still be public. But by using our protocol, we guarantee that the input, the execution, the output, and the transaction can be preserved privately. And we hope is that our solution can enable a lot of new applications for blockchain. So for developers, our hope is that they don't need to write zero knowledge proof circuits by themselves. They will still develop contracts very similar for they develop smart contracts for Ethereum, and our compiler will compile their private code into those protocols and zero knowledge proofs. And we will build our own chain to support this. One of the reasons is to improve the scalability, because a lot of zero knowledge proofs, it takes a lot of computation resource. We will have our own solution, for example, such as computation sharding, to improve the scalability for zero knowledge proof. And we will also provide better support for zero knowledge proof on our chain. And also, I think one important piece is we will enable the private transactions to better preserve the privacy for smart contracts. And here is some of the applications that we think could be benefit from this privacy preserving feature. For example, payroll contract, if you have a payroll contract, maybe you don't want outside to know how much you get paid. And in the insurance contract, since as I just mentioned, a lot of insurance is related with your personal data. We can use these techniques to make sure that those data will not be leaked to other parties. And also a lot of the trading or options and futures, since sometimes the price is quite sensitive, and it might also reveal like what are the risks that you cared about, so we can keep them private. And also for health applications, auctions, since the bid information is very important, and also for elections, people can choose to hide their votes. I hope that our platform can enable a lot of those applications, because currently it's still hard to run these applications on our public blockchain, because a lot of sensitive information will be leaked. And this is our roadmap. Basically, we will have a test net that enables confidential transaction at the end of this year, and we are going to release our main net on next year. And so this is a summary of today. Basically, we think that privacy preserving smart contracts will create a lot of possibilities for blockchain, and hopefully it can enable a lot of new applications. So we will strive to be the best application platform for private preserving smart contracts. And if you want to know more details about Origo, welcome to take a look at our white paper. And also this is our Telegram and Reddit channel. Thank you.